All right, let's take a look at problems number 1 and 2. The first one tells us that the absolute value of v is greater than 9. So the first thing I'm going to do is use the first rule of absolute values. I'm going to break this up into two different inequalities. V is greater than 9, and the other one is negative v is greater than 9. And because this is a greater than sign, my second rule tells me greater than, this is an or. So I have v is greater than 9 is one of the possibilities, or the second one is I have negative v here. I don't want to know what negative v is. I want to know what v is. So if I take my negative v and I multiply by negative 1, that will turn that into a positive v. That's what I want. But I can't just multiply one side of my inequality by negative 1. I have to do that to both sides. So over here I have negative 9. And of course our rule of inequalities is if I multiply or divide by a negative, I flip the sign. So I have v is greater than 9 or v is less than negative 9, and those are the two possibilities right here. So now I can graph it. V is greater than 9, so there's 10, so 9 would be right in between there. So v is greater than, and it's going to be empty because it is not a greater than or equal to. 9 is not going to be a solution. V is greater than that, or v is less than, and again I leave it open, less than negative 9. Our second question is very similar, but except it's a less than or equal to as opposed to a greater than. It's telling me the absolute value of m is less than or equal to 9. So once again, rule number 1 is I do the positive case, so m is less than or equal to 9. And I do the second case, which is that negative m is less than or equal to 9. And this is less than. So our second rule tells us that this is going to be an and. So once again over here, I have negative m is less than or equal to 9. I don't want negative m, so I'm going to multiply by negative 1 and multiply by negative 1. Negative times a negative is a positive. Negative times a positive is a negative. And because I multiplied by a negative, I flip the sign. So now I have two things. M is less than or equal to 9, and m is greater than or equal to negative 9. So at negative 9, it's greater than or equal to, so it goes to the right this way, and at m is less than or equal to 9, it's right here, and again that gets solid because 9 is a solution, and it goes this way. So if I want all the ones that are both less than 9 and greater than negative 9, then it would be all the things between. Those are the only ones that follow both categories of both there's an and that has to do both. Then the only ones that are greater than or equal to 9 and less than or equal to negative 9 are all the points in between. All right, let's take a look at problem number 3. Negative 4 plus the absolute value of 5 plus a is less than or equal to 2. So the first thing I want to do is isolate the thing that's in the absolute value, in this case 5 plus a. So I have this extra negative 4 here. What's the opposite of subtracting 4? Well, adding 4. But of course, if I add 4 to one side, I have to do it to both sides. So those cancel, and I'm left with the absolute value of 5 plus a is less than or equal to 6. Now I just follow the same rules we talked about earlier. The two rules are I have to split this up so it becomes 5 plus a is less than or equal to 6. And the other rule, of course, is that I take negative 5 plus a, and that's also going to be less than or equal to 6. And it's less than, so this is a and. Now I just need to solve these. So in this one, it's just 5 plus a is less than or equal to 6. And this one, I have to distribute the negatives. So negative times 5 becomes negative 5. Negative times a becomes negative a, and that's less than or equal to 6. So now I want to isolate my variables. I've got a, I want to isolate that. The opposite of, I have plus 5 to that. If I subtract 5, that's the opposite. So if I subtract 5 to one side, I do that to both sides. And I end up with a is less than or equal to 1. And if I add 5 to this one, because it's negative, add 5, I'm going to end up with negative a is less than or equal to 11. And I don't want negative a, so I'm going to multiply by negative 1, which is going to turn this positive. But if I multiply one side by negative 1, I have to multiply both sides by negative 1. So I get negative 11 on this side. And I need to flip it, so it turns around like that. So I have a is less than or equal to 1, and a is greater than or equal to negative 11. If either of those if both of those conditions are met, then this will be true. Both of those conditions have to be met. So I have a is less than 1. Here's 1. And it's less than or equal to, so it's all the ones going this way. And I have a is greater than or equal to negative 11. So here's negative 11. In between negative 10 and negative 12, and again it's greater than or equal to, so I'm going to fill that in because negative 11 is a solution. And if I want all the ones that are both less than 1 and greater than negative 11, that would be the ones in between, so that look like that. So problem number 4 tells us that the absolute value of n plus 3 plus 10 is greater than 20. So I want to isolate my absolute value part here. So I do that. I have it plus 10. The opposite of plus 10 is to subtract 10. And if I do that to one side, I need to do it to both sides. Now the plus 10 minus 10 cancels, and I'm left with the absolute value of n plus 3 is greater than 20 minus 10 is just 10. And now we do our first rule of splitting it up. So I have what's in the absolute value, n plus 3 is greater than 10, and, whoops, I did that wrong, sorry, the absolute value of what's in there is greater than 10, and it's greater than, so I'm going to make that an or, and also the absolute value, the thing that's in the absolute value, n plus 3, has to be greater than negative 10. Oh, I'm sorry, the negative of that has to be greater than 10. Sorry, other way around. The negative of that has to be greater than 10. So now I just have n plus 3 is greater than 10, or if I distribute my negative times a positive is a negative, and negative n, and I distribute my negative times 3 is going to be negative 3 is greater than 10. All right, so continuing on, I've got n plus 3. If I subtract 3 from both sides, I end up with n is greater than 7, or I have to add 3 here to both sides. So I have negative n is greater than 13. But I don't want negative n, I want just n. So if I multiply both sides by negative 1, Then the negatives cancel, and I'm left with n. And because on this side I have negative 13, and because I multiplied by a negative, I switch the sign. So I have n is greater than 7, or n is less than negative 13. So negative 13, let's see, in between here, this would be negative 14, so negative 13 is going to be right here. And negative 13 is not a solution because it's less than, not less than or equal to, and it's all the ones less than that. And then n is also greater than 7. So between 4 and 8 is 6. So between 6 and 8 is 7. That's 7 right there. And 7 is not a solution because it's greater than, not greater than or equal to, and it's all the ones greater than 7. All right, so let's take a look at number 5. Number 5 has 9 minus 2, the absolute value of 5 minus 8a, is less than or equal to negative 17. So I want to isolate my absolute value. So just following my rules of algebra, the first thing I would do is I have a positive 9 out here. To get rid of that, I would simply subtract 9. If I do that to one side, I have to do it to both sides. So the 9's cancel, and I have negative 2 times the absolute value of 5 minus 8a is less than or equal to, in this case that would be what, negative 26. Now I want to isolate the absolute value part, and I have negative 2 times that, so I would divide by negative 2, and I do that to both sides. So the negative 2's cancel, and I have the absolute value of 5 minus 8a. And on this side, I have a negative or negative divided by a negative is a positive, 13. And because I divided by a negative, I have to flip the sign to greater than or equal to. So now I would split this up. I have what's in the absolute value, 5 minus 8a. That's greater than or equal to 13. Greater than, so it becomes an or. And the negative of this, negative of 5 minus 8a, is also greater than or equal to 13. Because it's in the absolute value, just negative would be fine. Okay, so now I just have to isolate my variables. So I have 5 minus 8a is greater than or equal to 13, or distribute my negative. A negative times a positive is a negative 5. A negative times a negative is a positive, so positive 8a greater than or equal to 13. I want to isolate my variable, so if I subtract 5 from both sides, I end up with negative 8a is greater than or equal to, what would that be, 8? Or, if I add 5 on this side to get rid of this one, add 5, then again these cancel, just like these canceled over here. I end up with 8a is greater than or equal to, that would be 18. So now I want to isolate my variable, and I have negative 8 times a, so I would divide by negative 8 and do that to both sides. So the negative 8's cancel. I have a, and over here a positive divided by a negative is a negative. And because I've divided by a negative, I flip the sign. Over here, I just want to divide by 8. The 8's cancel, and I have a is greater than or equal to, and because I divided by an 8, a positive 8, just to stop, the sign stays the same, and 18/8 could be reduced into 9/4, which is the same thing as 2 1/4. So now I have to graph this. This is an or, so only one condition has to hold. So a is less than or equal to negative 1. So here's negative 1. Negative 1 is a value because it's less than or equal to, so I'd fill it in, and it's all the ones less than that. And then a is greater than or equal to 2 1/4. So if this is 2 and this is 3, that's 2 1/2. 2 1/4 is like right about there. 2 1/4 is a value. I fill that in, and it's all the ones that are greater than that. Okay, let's take a look at 6. We have 3 plus 5 times the absolute value of 10 plus 5x is greater than or equal to 53. So I want to isolate what's in my absolute value, and I have this positive 3 here. So if I subtract 3, that will cancel, but I've got to do it to both sides, of course, for balance. Those cancel, and I have 5 times the absolute value of 10 plus 5x is greater than or equal to 50. Now I want to isolate what's in my absolute value right here, but I have 5 times that, so I'm going to divide by 5, and I need to do that to both sides. So the 5's cancel, and I'm left with the absolute value of 10 plus 5x is greater than or equal to 10. So now I do my rule and I split that up. I say that 10 plus 5x is greater than or equal to 10. Greater than, so it's an or, and the negative value of what's in the absolute value, 10 plus 5x, is greater than or equal to 10. So now I just have to solve each of these two inequalities. So I have 10 plus 5x is greater than or equal to 10, or I have to distribute the negative. Negative times a 10 is a negative 10, and negative times a 5x is a negative 5x, and that's greater than or equal to 10. I want to isolate my variable, my 5x here, so I do that by subtracting 10. But if I do that to one side, I have to do it to both. That cancels, so I'm left with 5x is greater than or equal to 10 minus 10 is 0. I can do that one, or I want to, in this case, I want to get rid of this negative 10 here, so I'm going to add 10. And add 10 to both sides. That cancels, and I'm left with negative 5x is greater than or equal to 20. Now I want to isolate my variable. I've got 5x, so I want to divide both sides by 5. And when I do, those 5's cancel. I'm left with x is greater than or equal to 0. And on this side, if I divide by negative 5, and I do that to both sides, the negative 5's cancel. I have x. 20, or a positive divided by a negative is a negative. 20 divided by 5 is 4. And because I divided by a negative, I flip my signs. This becomes less than or equal to, and this is an or problem. So it only has to have one criteria pass for it to work. So I have x is greater than or equal to 0. So here's 0. It's greater than or equal to, so I fill it in because 0 would count. And it's all the ones that are greater than that. And then I have x is less than or equal to negative 4. So I go to negative 4, and negative 4 is a value, so I'm going to fill that in because it's less than or equal to, so it's equal to negative 4. And it's all the ones that are less than that, so I go this way. And so this is our final answer. It's all the ones that are greater than or equal to 0 and all the ones that are less than or equal to negative 4. Let's continue on with number 7. I have 10 times the absolute value of negative 2 minus 4x minus 1 is less than negative 21. So the first thing I want to do is isolate my what's in my absolute value. So I have this minus 1 here. If I were to add 1 to both sides, that makes this cancel, and I have 10 times the absolute value of negative 2 minus 4x is less than negative 20. If I divide now, I want to isolate what's inside here. I divide both of these by 10. Divide both of these by 10. So that goes away. I have what's in my absolute value is negative 2 minus 4x is less than negative 10. Okay, now let's stop and think for a second. Because whatever value I put in for x, no matter what it is, once I take the absolute value of it, it's going to be positive. So it's always going to be either 0 or greater than. It's going to be greater than or equal to 0. No matter what x I put in, it has to be, the lowest it can be is 0, and it's going to be positive. And this is saying it's less than negative 10. So what number could I put in what positive number is less than negative 10? And the answer is there isn't one. So as soon as I see an absolute value that's less than a negative number or even less than 0, then the answer is simply no solution. There is no number that I can put in here that's going to be less than a negative, because an absolute value makes whatever I put in here positive. So this is essentially saying, what positive number is less than negative 10? And the answer is there aren't any, none. So there's no solution. For number 8, let's do number 8. I've got 4 minus 5 times the absolute value of 10 minus 4x is less than 74. So if I subtract 4 from both sides, those cancel. I have negative 5 times the absolute value of 10 minus 4x is less than 70. If I divide by negative 5 on both sides, the negatives cancel, and I have the absolute value of 10 minus 4x is, on this side, a positive divided by a negative is a negative. 70 divided by 5 is 14. And because we divided by a negative, we flip our sign. So now this one is almost the exact opposite of this one. This is saying this thing in here, whatever it is, the lowest it can be is 0. But it's going to be a positive number, right? It's greater than or equal to 0. No matter what I put in for x, any value you possibly want for x, it's got to be, when I put it in an absolute value, it's got to be greater than or equal to 0. And this is saying, okay, well, this thing, whatever it is, it's always going to be greater than or equal to 0. No matter what it is, make that greater than negative 14. So it doesn't matter what value I put in for x. It's always going to work. Because whatever I put in here, going to make it positive, and any positive number is always going to be greater than negative 14 for everything. It always is true. So the answer for this one is all real numbers. So these two are almost opposites in a way. Problem number 7, if I have something that's less than a negative, then it doesn't matter what I put in for x. It can't possibly be negative, so there's no solution. And number 8 is saying that whatever is in this absolute value is greater than a negative. Well, that's going to be all real numbers. It doesn't matter what I put in for x. It's always going to work, because no matter what it is, it's going to be greater than or equal to 0. And any number greater than or equal to 0 is, by definition, greater than a negative. So it's going to be all real numbers.